Hello again. So let's continue from complementary energy principle. So ito yung ating main equation. Take note na pinagsama na yung moment tsaka yung shear dito. And ang kailangan natin ngayon yung vertical displacement V. Okay, so from this equation, C is equal to the integral of m1 f1x squared all over 2ei plus the integral of gamma f1 squared all over 2ga dx. Taking m1 and f1 as independent forces. Ang applicable dito ay partial derivatives. So we have f1 and f1. So ito na siya, no? And then it boils down to v1 is equal to 1 over ei times the quantity m1x squared all over 2 plus f1x cubed all over 3 plus gamma f1x all over ga, wherein both terms ang limit niya ay 0 to L. Okay, so in-skip na natin yung partial derivatives part. And then, dito, yung denominator niya, itong term na ito, ginawa nating isa. So, with a common denominator of 6. So, m1x squared now has a constant of 3. And then, f1x cubed, meron siyang 2. And then, yung 1 all over ei, dinistribute na natin siya dito sa dalawang terms na yan. Which boils down to 1 all over 6 ei times this quantity. Remember that this is V1. Ngayon, yung 6 ei, i-transpose natin siya para maging 6 ei V1. Okay, so tanggalin na natin itong mga bracket. So 3m1l squared plus 2f1l cubed plus 6 gamma f1ei l all over ga. So saan nanggaling yung L? Okay? Ito yun. Yan. Sinubstitute na natin yung L minus 0. Okay? Wherein 6ei v1 now becomes 3m1l squared plus 2f1l cubed times the quantity 1 minus 3 gamma ei all over gal squared. And then let beta equal to 12 gamma ei all over gal squared. Saan galing ito? Ito yon. Okay? So, isa-substitute natin si beta dito kay 6ei v1. So, magra-round siya into this equation. 6ei v1, v sub 1 becomes now 3m1l squared plus 2f1l cubed times the quantity 1 plus beta all over 4. Okay, notice na yung b, constant yan, wherein you have gamma, ei, tsaka yung area, tsaka g. These are all taken from the properties of your section. Okay, so what is left here, you have the moment m1 and your q f1. So let this equation be equation A. So, kanina, since this is partial derivatives, so, ito yung ginawa natin kanina, you have delta C, or with respect to F1. Ngayon naman, kukunin natin yung derivative of C with respect to M1. Ito na yun. Okay? Remember that M1, ang displacement na nagmumula sa moment is rotation or yung theta 1, which is now equal to the integral of m1 f1x dx all over ei plus 0. And then, integrate natin from 0 to L. Theta 1 now becomes 1 all over ei times the quantity 2m1x plus f1x squared all over 2, ranging from 0 to L. Okay? So we now substitute L to this quantity, tapos yung 2ei transpose na natin dito. So therefore, 2ei theta 1 is equal to 2m1l plus f1l. And then, saan galing itong equation na yan? m1 is equal to, which is basically from this equation. So, in-isolate lang natin si m1. Okay? So, 2ei theta 1, si f1l squared, ilipat natin sa kabila. Kaya siya naging negative dito. And then, divided by 2l. And then, notice that in this equation, ang naiwan na lang sa dito sa right term is m1 tsaka si f1. And then, ganon din dito sa equation A, meron pa rin si m1 tsaka si f1. Now, going back here, this is now equation B, 2ei theta 1. Okay? And then, from this equation again, i-isolate natin si f1 and this will be your equation. Okay, so 2ei theta 1, i-minus natin 2m1l kasi i-transpose natin siya, and then divided by l squared. And then, itong f1 na yan, isa-substitute natin kay equation A dito. Okay? And then, we solve for m1. Ayan. So, yung f1 kay equation A magiging 2ei theta 1 minus 2m1l all over l squared, which is this equation. Ano? And then, itong 3m1l squared, i-isolate natin siya. Okay? So, 3m1l squared is equal to 6ei v1 minus, ito yung 2f1l, lilipat natin dito sa kabila. Ito na siya ngayon. Okay? And then, magkakancel ngayon yung l squared tsaka l cubed. So, matitira na lang dito yung l. Which boils down to 6ei v sub 1 minus 4l times the quantity ei theta 1 minus m1l times the quantity 1 plus beta over 4. And then, look at this equation. So, ei theta 1 times 1 equals this. Minus m1l times 1, which is this, plus ei theta 1 times beta all over 4, which is this. And then, minus m1l multiplied mo siya kay beta all over 4, which is this equation. And then, since parehas itong all over 4, so pinag-isa na lang natin siya. We now distribute 4l to each of the terms inside the bracket. So ito siya. So minus 4 ei theta 1l plus 4 m1l squared. Ito. Plus yung 4 tsaka yung 4, magkakancel na yan. And then, ei theta 1b times l, kasi meron kang l dun, minus m1 l squared b. But take note that this is negative and then negative, kaya siya naging positive dito. Again, this is 3m1l squared, ano? So, balik ko lang siya dyan. Tapos, we simplify further. Lahat ng terms na may m1, ililipat natin dito sa left side. Ito siya. And then, we simplify again. Okay? So, yung 3m1l squared, ayan. Tapos, yung 4m1l squared, ililipat natin dito sa left. Kaya siya naging negative. Tapos, si m1l squared b, positive, nilipat natin siya sa right. Kaya siya naging negative. Okay? So, ito yung mga m1l squared. This is common. So, m1l squared times the quantity 3 minus 4 minus beta. Okay? This is equal to these terms. Ayan siya. And then, 3 minus 4 is equal to negative 1. Okay? So, this is negative 1 minus beta. Ilabas mo na lang yung negative dito para maging 1 plus beta yan. Okay, and then, itra-transpose natin si negative 1, si L squared, tsaka si 1 plus beta para ma-isolate natin si M1. So, finally, M1 now becomes this equation. EI times the quantity 6B1 minus theta 1L times the quantity 4 plus beta all over negative L squared times 1 plus beta. And then, i-isolate natin yung mga displacements. Okay? Take note na ang displacements natin, you have V1, tsaka yung rotation theta 1. Okay? V1, that is the vertical, and then theta, the rotation. And then yung mga constants, o yung mga based on section properties, elasticity, moment of inertia, tsaka yung beta, ilalabas natin siya as much as possible. Okay? So, eto na siya. So, theta 1 all over negative or negative divided by negative magiging positive siya. And L over L, magkakancel out yan. So, this becomes theta 1 times the quantity 4 plus beta. And then, 1 divided by negative would be simply negative. So, this is minus 6V1 all over L. So, ito na ngayon yung equation natin for M1. And then, we will substitute M1 to equation A para makuha natin si F1. Okay? Okay? So, ito yung nasolve natin. So, substitute natin ito kay equation A. Ito siya. Ulitin natin. Taking M1 from B and substitute at A, hindi ito yung kukunin natin, but instead, ito, this is from B, ano? Ito yung kukunin natin. So, isa-substitute natin itong M1, which is 2EI theta 1 minus F1L square all over 2L dito kay equation A. Okay? So, 6EI V1 is equal to 3 times the quantity, which is this. Okay? And then, it all boils down to this equation. Okay? So, ulitin ko. Isinubstitute natin ito dito sa equation A. Naging ganito siya. Okay? So, we will skip that part. Madali na lang gawin yon. And then, we simplify this. So, itong 3L all over 2, i-distribute natin dito. So, magiging 3 EI theta 1 times L plus 3 halves F1 L cube. Bakit naging plus yan? This is negative times negative. And then, lahat ng unknowns which is connected to V1 and theta 1, i-isolate natin yan, ano? Or lahat ng variables na V1 and theta 1, ilalagay natin dito sa right. And then the rest dito sa left. So we have 2F1L times the quantity 1 plus beta over 4. Tapos si 3 halves F1L, ano? Ito, wala siyang V1, wala din siyang theta 1. So, ililipat natin siya dito sa left. Kaya ito siya naging negative. And then, 6EI V1, tsaka si 3EI theta 1 L, dito siya sa right side of the equation. And then, notice here at the left equation, left part of the equation, F1L cube is common. So, 2 times the quantity 1 plus beta all over 4 minus 3 halves. And then, dito sa right term, common din si EI. So, we have EI times the quantity 6V1 minus 3 theta 1 L. And then, dito sa left term, gumawa tayo ng common denominator nito, yung dalawang yan, which is all over 2. Okay, so itong 2 magiging 4 na yan. 2 times 2 will give you 4. Ayan. Okay? Tapos, itong denominator na 2, ilabas natin siya rito. So, magiging F1L cube all over 2. Tapos, isimplify na natin itong taas. So, this now becomes 4 plus beta all over 4 times 4, magkakancel yung 4. So, this simply becomes beta, then minus 3. Okay, tapos i-retain natin itong equation na yan. And then, 4 minus 3 is simply 1. Okay, so F1L cube all over 2 times the quantity 1 plus beta is equal to EI times the quantity 6 V1 minus 3 theta 1 L. And then from this term, i-isolate natin si F1. Si L cube, 1 plus beta, tsaka si 2, ilipat lang natin dito sa right term. Okay, so F1 now is equal to 2EI all over L cube times 1 plus beta multiplied by the quantity 6V1 minus 3 theta 1 L. And then, ipakita ko lang itong equation ni M1. Yung constant niya dito is EI all over L1 plus beta. Gagayahin natin ito para kay F1. Okay? So, dapat EI all over L times 1 plus beta. So, yung 2, i-distribute natin yan dito sa loob, pati na rin yung L cube. So, this 6V1 now becomes 12V1 all over L squared. Okay? Bakit naging L squared yan? Kasi, yung dito sa constant, nag-iwan tayo dun ng L. Okay? So, L times L squared will give you L cube. Tapos itong minus 3 theta 1L, i-distribute natin si 2, tsaka si all over L squared. So this becomes now negative 6 theta 1, okay, all over L. Okay, so magkakancel ngayon yung L. Okay, bakit naging L na lang ito? So, remember na dito sa labas, nag-iwan tayo ng isang L. So, ang papasok ngayon dito sa loob is L squared. So, L all over L squared will give you 1 all over L. Okay, so this is now the equation for F1. Notice na yung constant, you have EI all over L times 1 plus beta. Common yan kay M1. Ito siya, no? So, M1, EI all over L1 plus beta. Ganun din kay F1. And then, ini-rearrange din natin yung terms. Mauuna yung rotation, susunod yung vertical displacement V. Ganon dito kay M1. Nauna yung theta 1 or rotation, sumunod yung vertical displacement V1. And then from equilibrium figure, which is ito galing dito sa complementary energy, ito yung figure niya. So we have here M2 is equal to negative F1 minus F1L. Okay, so we will substitute now si F1 dito kay M2. Okay, so M2 now is equal to minus F1 minus F1L. Yung F1, negative F1 naging positive 6 theta 1 all over L, no? Ngayon, yung M1, ulitin natin, ano? Si M1, isa-substitute natin dito. Okay, so, theta 1 times the quantity 4 plus beta. Ito yun. And then, 6V1 all over L. Ito yun. So, this is essentially your M1. Pero, remember na dito sa equation na to, M1 is negative. Okay, so, ang common term ni M1 tsaka si F1, remember na, ang common term ni M1 tsaka F1 ay EI all over L1 plus beta. Okay? Kaya, meron din siyang negative dito kasi originally negative yung M1. And then, negative times negative, kaya naging positive ito. Okay. Tapos, nilabas na natin si EI all over L1 plus beta. Now, let's go to negative F1. Which is this. Again, yan, common siya. So, nilabas na natin ito. Tapos, i-multiply natin ng L. Okay, so this now becomes 6 theta 1 times L all over L. And this is negative, tsaka negative yun, kaya naging positive ito. Okay, so ito naman, 12 V1 times L all over L squared. Okay? And then, ito, yung positive, magiging negative kasi dito mayroong minus. Yan. So, from this equation ngayon, magka-cancel yung mga length dito. Okay? So, further simplifying this equation, M2 now becomes EI all over L times 1 plus beta multiplied by the quantity. We now distribute theta 1. So, this now becomes negative 4 theta 1 minus beta theta 1 plus 6 theta 1 all over L. Ito yon. Okay? And then, si V1 all over L, tsaka ito, common. Ano? So, ito ngayon si 6, napunta riyan, tapos si minus 12, ito siya. Okay? And then, simplify ulit natin ito. Itong 3 terms na yan, common si theta 1. Okay? So, ilabas natin si theta 1. So, 6 minus 4 now becomes 2, and then mariretain si negative beta. Tapos, 6 minus 12 will give you negative 6. Okay, so mapapansin nyo na na-rearrange na naman itong term. Nauna yung theta 1 or yung rotation, susunod yung term involving the displacement v1. And still from the equilibrium conditions, F2 is equal to negative F1. So susundin natin yan. Okay, so F2 is equal to negative F1. Pero nasolve na natin si F1. Okay? So, substitute natin ito. So, F2 now becomes EI all over L times the quantity 1 plus beta times the quantity 6 theta 1 all over L. Ngayon, bakit naging positive na yan? Negative times negative, ito, will give you positive. Okay? So, negative times positive, magiging negative 12v1 all over L. And then, repeating the procedure from complementary energy principle, okay, ito yung ating figure, yung member, okay, so we have F1v1 dito sa point 1, dito sa other end or point 2 we have F2v2, and then applying support at end node. Okay, so let's say nag-cut tayo dito ng section or nag-cut tayo rito. Itong end node, ginawa natin siyang support. Okay, so we will apply this principle, but this time bubuhayin natin yung F2. At ang gagawin nating support ngayon si point 1. Which is now this. Okay, so ito si point 1, naging support na siya. Si F2, yan na ngayon yung free end. At meron pa rin siyang M2. And then, nag-cut tayo ng section dyan. Okay, this is now distance x. And then you have L minus x. Now, from this figure, your moment M is equal to negative M2 plus F2 times x. Yung moment na yan, yan yung rotation dito sa fixed support. Okay? Tapos, taking counterclockwise as positive, ano? Taking counterclockwise as positive, yung M2 mo, naging negative siya. Tapos, si F2 multiplied by X, magiging positive. Oh, sorry. Ito palang moment na yan, this is the moment at the section, ano? Not at the support. Or this is at any section defined by distance x. So, the moment M at this cut section is equal to negative M2 plus F2 times x. And then, yung shear, remember that shear yan yung vertical forces. Ang shear ngayon dito, or vertical force, you have negative F2. Tapos from equilibrium, your moment 1 is now equal to negative M2 plus F2L. And then we repeat the same procedure. Makukuha natin ngayon yung si M2, okay, tsaka si F2. And then from equilibrium conditions, ito, from this equation, i-isolate natin si M1, ano? So, M1 becomes now negative M2, okay, minus or plus F1L, okay? Negative M2 plus F1L. But, ano si F1? Okay, ulitin ko. From this equation, i-isolate natin si M1. So, magiging M1 is equal to negative M2 minus F1L. Pero bakit naging positive F2L dito? Dahil dito. Okay? F1 is equal, negative F1 is equal to F2. So, you substitute this para maging F2 yan. And then, since nasolve na natin si M2 tsaka si F2 in terms of theta tsaka V. Okay? Sorry for that. Si M2 tsaka si F2 na-solve na natin in terms of V2 and theta 2 now, no? Kanina, sa first complementary equations na solve na natin si theta 1 tsaka si theta 1 tsaka si V1 and M1 tsaka F1. Okay, dito naman ngayon, i-substitute natin si V2 tsaka si theta 2. Okay, so M1 now becomes this equation and F1 is equal to negative F2. Galing pa rin yan dito sa equilibrium. So, i-summarize natin ngayon yung equations in terms of F1, M1, F2, tsaka M2. Ayan, from complementary energy, ang una nating na-solve dito ay si M1. Okay, ayan. So, EI times divided by the quantity L all over 1 plus beta. Ito yun. And then, you have negative 6 V1 all over L. Ito siya. Plus 4 plus beta times theta 1. Ito yun. And then, saan nanggaling itong V2 tsaka theta 2? Ito naman yun. Ano? So, we have 2 minus beta theta 2 tsaka 6V2 all over L. So, pinag-combine na natin yan. Next. We have F1. Ito. In terms of theta 1 tsaka V1, ito yun, ano? Minus 6 theta 1 all over L. Ito yun. Tapos si 12V1 all over L squared. Ito yun. And then, isali rin natin yung V2 tsaka theta 2. Ito yun. Saan nanggaling yan? Ito yun. Okay? So, we have 6 theta 2 all over L. And then 12 V2 all over L. Bakit negative? Okay? Remember that F1 is equal to negative F2. Okay, tapos na natin si M1, F1. Ganon din kay M2 tsaka kay F2. So, saan nanggaling itong M2 ngayon? Ito si M2. Okay, we have 2 minus beta times theta 1. Positive siya. And then minus 6V1 all over L. This is in terms of V1 and theta 1. This refers to your point 1. Pero meron din in terms of point 2, V2, tsaka yung theta 2. Nanggaling yan dito. Still part of M2. Yan. Okay? So, 6v2 all over L, and then yan. Theta 2 times 4 plus beta. And then finally, we have your F2. Ayan siya. F2, we have 6 theta 1 all over L. Ito. Tsaka minus 12 V1 all over L squared. And in terms of point 2, or theta 2 tsaka V2, dito naman siya manggagaling. Okay. Ito. Okay? So, 6 theta 2 all over L plus 12 V2 all over L. So, ito ngayon yung ating summary ng equations. And then, i-convert na natin siya in matrix form. Okay? So, ito ngayon yung column matrix in terms of forces and moments. Ito yung common term or constant, EI all over L1 plus beta. Tapos, ang unknowns natin dito ngayon, you have, for this column, you have V1. And then for this second column, you have theta 1. Take note, ang ibig ko sabihin, this column, we have theta 1, theta 1, theta 1, tsaka theta 1. And then for this column naman, you have V2. Okay? And for the last column, you have theta 2, which happens to be this column matrix here. So, ito yung augmented matrix, meaning in-isolate na natin yung displacements. Ito naman yung forces. Tapos, ito ngayon yung kanyang components. Okay? You have 12 V1 all over L squared. Ito siya. Pero yung V1, nandito na sa labas. Okay? Ito naman, 6, negative 6 all over L. Ito, negative 12 all over L squared. Yan. So, take note that in this matrix, yung V tsaka theta, these are unknowns. Tapos, itong square matrix na yan, this is square kasi you have 4 rows and you have 4 columns. Okay? Lahat ito galing yan sa beta tsaka sa L. Okay? Yung beta mo, galing yan sa properties. The L is simply your length. Now let's look at the displacements of a member. Ito yung let's look at a diagonal member with end nodes 0.1 and 0.2. Dito rin, you have 0.1 tsaka 0.2. In this figure, you have the vertical displacement V1, V2, tsaka horizontal displacement U1 and U2. And then you have the rotations theta 1 and theta 2. Dito naman, you have the elongation UA1 tsaka UA2. Okay, tapos you have the normal displacement Vn1 tsaka Vn2. Normal in the sense that it is acting 90 degrees with the length of the member. Okay, so take note, yung rotation theta 1, hindi siya nagbago with respect to this figure kanina. Okay, guys? And then, ito yung displacements. As I've said before, kapag may displacement, meron siyang katumbas na force or merong nagtutulak. So, ang katapat ni V1 na force, you have Fy1. Okay? Since this is vertical, your force must also be vertical. Kay V2, you have Fy2. Kay U2, this is horizontal displacement at point 2, you have Fx2. Now, the corresponding force for U1 or horizontal displacement at point 1, you have fx1. Okay, so it makes sense now. For theta 1, the corresponding moment, you have m1. And for theta 2, you have corresponding moment 2. Likewise, dito naman sa axial force. For UA1, you have FA1. For UA2, you have FA2. And then for normal displacement VN1, you have FN1. Okay. So kanina, nakuha natin yung matrix form ng mga vertical tsaka yung F1 tsaka M1, F2 tsaka M2. Okay? So, same thing with your normal forces, Fn1 tsaka Fn2. Okay? So, kay Fn1, ganun din, 12 all over L squared minus 6 over L minus 12 all over L minus 6 all over L. Pero yung kanyang displacement, you also have Vn1, theta 1, Vn2, tsaka theta 2. Mapapansin mo na yung moment 1 dito sa normal is the same as moment 1 dito sa sinold natin kanina. Okay? You have minus 6 all over L, 4 plus B, 6 all over L again, and then 2 minus B.